I represent L&T Technology Services. I would just talk a few lines on that. So L&T Technology Services is part of L&T umbrella, the $25 billion Larsen and Toubro. Needs no introduction. L&T Technology Services is a publicly listed L&T organization, $1.1 billion company, and it is there across 53 different countries across the world, around 24,000 employees, and working in various technology segments. And we specialize in ER&D, so engineering, research and development areas in various sectors of 6 different verticals spanning product technologies and process technologies. I represent a plant engineering organization, which is there to support design and development and detail engineering for various chemical, oil and gas, FMCG plants across the world. So lot of discussions on digitalizations, and you have heard the perspective from Aviva, the software manufacturers, the owners of software platforms. You have heard what digital twins platforms available, what Aviva's products can do that. You have heard from all the owners, operators in the panel. My distinguished panel speaker members were there who talked about their challenges of each and every plant that they have faced and how they have been able to overcome them using a lot of digital technologies, what trends. So what is the difference that I would like to bring is a perspective from engineering consultancy organizations perspective. The trend that I'm going to talk about is going to tell what is that difference coming in existing plants, what are the RFQs that you are receiving, what are the requests for collaborations, development of proof of concepts that we're getting from all of our customers across the globe. And at the same time, for a new plant, what is that customers are thinking? These are the 2 things that would be my focus. And I would also be talking about implemented case studies of digital twins that has been implemented in some of these customers' areas. Oil and gas, couple of examples I have taken, but applicable for chemical. So for want of confidentiality, I'm not taking name of clients. We have also implemented for multiple customers, chemical customers also in India. So I would not be taking any, forgive me, I cannot take names and details of plant details, but I will be covering what is that we have done it. So this is how is me. And me, as I have already introduced about it, I am responsible for digital solutions that are required. So I bridge a gap between the IT engineers and the engineering organizations that try to understand what is that in IT that could be involved here. Most of you are here, chemical, mechanical, instrumentation engineers. I spent 12 years as a head of instrumentation for this organization, and automations, and also many of my, I also worked for 3 years as embedded design solutions as well. And then I worked as deputy head of engineering. So across mechanical, electrical, civil. So I am able to see the differences across multiple disciplines and the digital segments that is moving forward. So that is the perspective, and that's the gap that I try to bridge. So I would first talk about what is that in the run and maintenance phase of the plant. You have design phase complete. I'll talk about the design phase next. And if you look at it, these are the various areas. Okay, so if you look at from the left side, you have, I've tried to divide it into various places. For safety, I think one of my panel speakers, he talked a lot about safety and how safety is important. And what are the requests that we're getting in safety is safety as a whole. Okay, so organizations are looking at safety in all areas. So it's not restricted to hazards and hazard studies and all, which is part of design and all, but safety for an operating plant. So you have safety for hazardous area safety, and you have got accessibility, machine safety and guarding, especially applicable for FMCG areas. Workers and personal safety during the running of a plant or a construction of a plant. And also incidents management. If there are running plant incidences that happen, how do you capture those incidences digitally and immediately at the same point? So there are solutions available, and we're working on providing a lot of solution into that. A complete plant safety management portal, which talks about safeties in all areas, and you'll have available information, dashboards available, and unsafe behaviors are also tracked by video analytics, by cameras and all. You have unsafe behaviors are captured and tracked also. Then there are digital device accesses. So these are all requirements coming up. Multiple accesses within the administrative area, within process area, restricted areas. How do you want to do accessibility of people into those areas? Then administrative buildings are evolving into more and more. You look at any new plant, a new administrative building of a brand new plant, you would feel like you are getting into a five-star hotel. You have accessibility, very clear guidance of visitors, how they have to go inside the plant, customer access centers, visitor management systems, visitor management portals. These are the requests coming within the plants. And also have lot of improvement of production planning. MES have been implemented for ages. I'm not going to talk of MES, everybody knows about it. But the production planning expectations are rising, and everywhere the requirements are coming on inventory management and equipment availability. So production planning connected to overall equipment efficiencies of a plant and availability of equipment are also connected. There are one thing on AI ML based enabled operation and maintenance things are coming up. So you have all rotating and static assets. I think one of my panel members from Reliance, they talked about the implementation of AI ML based solutions. I think these are the things that are coming from a lot of chemical companies here. So all critical equipments identified by the criticality assessment, and then you look at what is the availability of equipment, and how do you decide that? It's again a hybrid approach, both a physics-based calculations and AI/ML-based systems. So you have chemical engineers who have to do all the calculations and identifying what should be the anomaly situations, and then that goes to the data scientist team. They design the systems, so that the anomalies those are generated are much ahead of the control system that responds. The traditional DCS system, much before it responds, you would be able to identify the anomalies and take executive actions on that. And environment management for emission monitoring and effluent discharge systems, and also what is that coming? Environment management systems are always there in a plant, but the difference that is coming out is how are you able to look at the complete environment management, environment monitoring and assessment systems very clearly in a click of a button, and also do planning for your next year. So if I want to see what would be my energy efficiency requirement for next year, where am I today, you'll be able to see that. So those are the requirements that are coming in an existing plant. I would now go to the next, the design stage interventions. I think this is where lot of interventions are coming. Like we, as I said to you, we operate majority in the detailed design, feed and detail engineering design of a plant. So it's no longer that the digital intervention happens after the design is complete. That's the traditional approach. Everybody used to do that because there's a competitive environment, so you don't get a lot of money for project phase. You have a budget for the project, and subsequently there is an operations budget. So there are a lot of design interventions, digital interventions are not done at the design stage. After the design is complete, you do the retrofitment, addition of it. But that's changing. That's the major thing that I wanted to highlight here in this forum, that people are talking on, we get requests from customers, right from concept stage itself, what is that we want to do? So that's what we're calling that as a digital master planning. So for a greenfield plant, you have a complete site-wide master plan. You know what are my process systems and production systems going to come 3 years, 5 years down the line. What is my future plan, stage 1, stage 2. So the complete master planning is carried out as part of engineering design. In similar fashion, master planning is planned for digital systems that you have to do. What is the digital interventions I have to do at the design stage itself? So in feed and detail engineering, so integrated design environment. So I think Jay Kumar talked about a lot about Aviva's integrated design environment. You have Aviva's overall Aviva Net and all, where all, different disciplines collaborate here. I think he's explained, I don't need to talk about it, but that's the expectation at design stage. The collaborations and stakeholders involvement at design stage it's no longer that, you have to do a 3D model design, sit in one room and look at a screen and then do a model review. No, you'll have people, they are remotely located, accessing the 3D model through a AR VR review. I'm going to show a couple of slides on that. Getting into the avatars of the stakeholders, getting into the 3D model, carrying out the reviews in terms of operational access, in terms of maintenance access, and giving the feedback right then and there. That's the kind of reviews in 30, 60, 90% of design that is being done, which we are implementing in multiple customers areas. The handover documentation is planned much in advance at design stage. Now, this is one pain area because any engineering company completes its activities after the design is there or the completion is done. If they carry out the construction management support after mechanical completion, they will hand it over. Or the EPC companies will carry out their part of the job and then leave it. And then when the operations team takes over, that is haywire. There are so many things which are not in place. You don't have standards followed by all stakeholders together. You don't have a single moment of truth of the design information. So there is a handover documentation, digitization plan is there right at the start of a feed level of a project. The same I just talked about, whatever decisions that we just talked about in my first slide, that you would like to do in an existing plant, those are being planned right at the start. So what's happening is you want to decide on what should be my interfaces for equipment. Okay, so IoT enabled equipment specifications should be written at part of your detail engineering design. You would ask the equipment vendors to supply those interfaces, equipments with those interfaces, so that you don't have to do again a retrofitment of an existing equipment after the plant is built. That's the expectations coming out. What would be my site-wide access, whether I want to have a, antennas need to be put across the plant so that I have device access is there. How would I do the fleet management? The moment the a truck is entering into the factory, from that time onwards, I want to track the truck. So those plannings are done. So that is helping, giving a direction to your civil design, giving a direction to mechanical design, equipment specifications design, all that are getting included at the start of the project. So this is a major trend, I would like to say. And if organizations, many of you sitting here, if you are thinking of a greenfield plant, you must think how my plant is going to be digitally enabled plant, such that the moment I start my operations, I have a digital twin of all informations and single moment of information of truth is available. That's the plan. I think I would request people to look into that. So I have some case studies. So this is the very, very common part of it. You have a Jay, again I would refer to Jay. I think Jay has captured a lot of things that I wanted to talk here, and we have already implemented that. So for an existing plant, you need to have the realty data. So as building is no longer required. The mistakes of each and every person. So somebody taking a hard copy of a PNID and doing a red line markup, going to physically the plant, how accurate that information, because we do that. We get red line markups up when our design is complete. And we send our engineers also to do that, but we never sure if everything clearly captured. That used to be the thing. But with laser scanning, that part is actually taken care. Of course, there are issues of if you have a jacketed pipe or if you have underground things, those things cannot be laser scanned. But by and large, all equipments and pipings get very well covered, and there are no issues in terms of the reality what is there. Of course, in geospatial data, all that into a part of a common data environment, you put them that. And then, as you know, Aviva also has this AIM portal, and also similar portals are definitely there, people are using. And of course, Aviva has a very, very developed portal in terms of accessibility, and ease of maneuverability is also much better in that. So you have all that information in one AIM portal, and you have got seamless navigations across 1D, 2D, 3D data and all. And of course, the expectation at the design stage is about 4D integration. So the construction, when you do a L3, L4, L5 level construction schedule done through Primavera, the expectation is that that should be linked to the 3D model so that I should know exactly on this date what am I supposed to construct, whether it has been constructed or not, superimpose the data and see that. And I think that has been implemented. We have done an implementation with a chemical customer, and of course that was in China. We did that just before COVID. We did it. After that, no access to China. So that was very, very well done. And I think we got around 1.5 to 2 months time it took for completing the schedule and the linking and implementing it site. We're also doing this thing to one of the refineries in Netherlands. We are doing it for a 4D construction implementation there. And the cost factor, the 5D data also is coming into factor. So you would know what is my planned cost on today, how much is going to be cumulative cost that would have been there, and what is my actual cost. So that information here. So a couple of examples of oil and gas refinery, but it is same for chemical also. I couldn't share a Indian client thing which was, I didn't get a clearance, so that's why I'm not shared here. So we have, I don't have to talk much. I think it is pretty covered there. So you have directly from a Google map also, there are many expectations to go direct to the plant level, the equipment level and detail level and coming out of it. This is the laser scanning and intelligent modeling of it for a very large refineries across. Of course, this is a US implementation. If you look at the number of pipelines, 11,500 lines and 1,800 equipment, so all of you know how large would be the implementation, close to 9 months, 8-9 months of time it took. So multiple laser scans. So as I said, I will be talking about the implementations that you have done. So these have been done with 3-4 engineers there, and of course you have to use special scanners which are suitable for hazardous area. You cannot take a regular scanner to there because they won't be acceptable, or it's not. So hazardous area safe scanners are there, and you have to utilize it as, and the piping isometrics generated 2 millimeter accuracy. Straight away you can do brownfield project. Of course, we have huge amount of data that needs to do, engineering has to be done to integrate it from the laser scan. Of course, we used Aviva for here, and you have Aviva Point Cloud Data Manager. Very comfortably you can convert that E57 files you receive, and you have Point Cloud Manager data, then you derive all the 3D models out of it. There are clash managers. Aviva Clash Manager we use to find out clashes and all between structures and pipings and all. Because you get a 3D model, a laser scan, it will feel that you put a scan and then you come out of it and you get a correct one. No, there are so many issues which come. You would say multiple different overlaps and all. Many times you have to carry out double lasers, multiple times scanning also, many areas you have to do it. And when you have to take that data and you convert into intelligent thing, multiple problems come which we have overcome, and we have a center of excellence which caters to this only, creating digital twins for existing plants. This is one here. Of course, we use Aviva ERM. We are the largest team for Aviva ERM users, and largest E3D team for converting this, and multiple plants we do that. And this is again for another oil and gas measure here. So here we have to first define, what do you want to do as intelligent modeling, what you want to do as a non-intelligent modeling. Structures and all you can't do intelligent modeling. All piping, equipment, instruments, these things you can do a very well intelligent modeling after you do that from scan, because what you are doing is a 60-year-old refinery. There are 50, 60-year-old, and their documents are on paper, scanned document. So we have to also use many times to digitize those scanned documents also. With different tools and all we use, and many times convert them to scanned copies and all. Many of these documents, on one of our on-site engineers he has to go and get some not there in the document vault also. Something is there in somebody's drawers and also. I'm saying this is situation in US. Forget about India. So it's nothing better. So this is where I think major thing that I talked about. As I talked about design reviews with AR, VR, I just said this is one of the interventions that are very, everybody is asking about this, and we are finding huge amount of benefits out of that. Because what is happening is generally during design, when you do the design, the operations and the plant team, they get only after 90% review of the 3D model. And by that time, so many things, equipment, a 90% level means your equipments are already ordered. And you are supposed to get all their footprints, and those actual footprints are already put into the model. And a huge amount of rework used to come. So we started involving those people from 60% onwards, and traveling and all our issues and all. So COVID time, we had a very good help because of this, because remotely located people were able to contribute to these design reviews and do that. And the same thing, so of course, this use a headset, MetaQuest headsets and all very common ones. And this also is useful for during construction also, during operator training also. So we have prepared operator training packages using this same 3D model. So you just look at that. What is the expectation? The same 3D model, 10, 15 years, 20 years, earlier story, 3D models once made by a design engineering company lies somewhere. It is never used. It was decided for design, something got constructed, it is updated, modified and all, it never gets changed. No need. Plant is constructed. It's no longer the case. 3D model is used till operator trainings, new operators joining, training of them, complete operation life cycle of the plant. So that's here. This I talked about, just listed down various benefits during design, during operations and all. And I'm done. Any questions? Thank you.